Okay, so the key thing too when you're looking at the problems that you're going to see in a couple weeks is they will never tell you extra clues. So if they're telling you that this is true and this is true, we're going to use them. Okay, so let's see for number one. How do you estimate a derivative from a table? Usually you have things on either side, but they told us that this function is concave up. This means the function is concave up, which means that f prime is increasing. So if we look at calculating the derivative from these 2 points, that's 2 and that is 12. If you estimate f prime this way, that'd be 12 over 2, which is 6. And then if you do between these 2 points, this is still 2, but now this is 18. And so if you estimate the derivative using those 2 points, you get 18 over 2, which is 9. But this is increasing and concave up. So what happens is, if you sort of think about 3 points on a curve, okay, if you do these 2 points on the left, you see that flat part? And then if you do the 2 points on the right of 7, and that's actually the derivative at 7. This number is too small, this number is too big. F prime is actually in between. So the only number in between 6 and 9 in this list is 7. Okay? Okay, let's do another one. Okay, so now they want us to estimate f of 20. And the last point we have is we know that f of 11 is 135. So we know about the derivative. This tells us how the function's changing. The function's changing with the rate that's somewhere between 1 and 10. So let's kind of estimate f of 20. We'd start at 135. We would be changing with the rate of 1. How many units would we be changing for? We're going from 11 to 20. So that's 9. And so this gives me 144. So that's the lower bound. And we can do the same thing if we, so this is the lower. It's the lowest it can be. It should be a little bit higher too because it's strictly bigger than 1. And what if the derivative was always 10? We have the 135 plus 10 times the difference between 20 and 11, which is 9. And that gives me 225. So that's the highest bound. So the only number in between is this 210. All right. Here's one that I totally hope is going to show up because you guys are going to walk in and you're like, I got this one, Miss Brady. Okay. How do you estimate a derivative from a table? You look for the 2 points that are closest to it and you just do slope or AROC. So this is 111 minus 93 over 9 minus 7. You can leave that on the real test, but I think we already did that. When we did that, we got 9. Okay, now let's look at some integrating. Okay, so we talked about integrating using Riemann sums. So make sure that you're looking at your table. We're going from 11 to 5. So that is the whole table. And there are 1, 2, 3, 4 points, which means that we have 3 regions, and each region has a base that's 2. So instead of doing 2 times 3 different things, I'm going to multiply 2 by everything. And between these 2 things, this one's on the left. So I'm going to use 2 times 81 plus 93 plus 111. And I think when I grabbed my calculator, it gave me 570. All right, next one. So let's do a bunch of integrals. Okay. All right, so here we go. First, look at the integrand. The integrand's f prime, and they gave us f. So they gave us a table with the antiderivative. So this is BAM, fundamental theorem. This is f of 11 minus f of 5. And I can just use the table. I think that's 135 minus 81, which you can leave. I think that's 54. Okay, you're like, oh, this is kind of the same idea, except this has to be just a single variable. So you're like, bam, use substitution. So u is 2x plus 1, which means du is 2 times dx, which means I need a multiplier of 2 here, which means that multiplier of 1/2. And if x is 1, u is 5. Is it 5? Oh, sorry, I want to change this to 2. So that would be 5. And then if x is 5, u would be 11. So this would be 1/2 of the same thing we did before, 54. Because this is 1/2, 5 to 11 of f prime of u du. Okay, next one. Okay, now this is an indefinite integral, so its output is a function, and I think we'll say that this is u. U is f of x squared, which means du is f prime of x squared times 2x. And so this needs a 2 here, which means this needs a 1/2 here. And then I can rewrite it. It's 1/2 of e to the u du. Okay, the antiderivative for e is itself, so I have 1/2 of e, but we're not doing u, so just swap back in what u was, and then add c. All right, last one. Okay, we need a tangent. You guys are awesome with it. Let me just change colors. Alrighty, so we know we need y minus something, slope x minus something, and they want to do it at 5, so we know that that's 5. Now we need g of 5, which is 10 plus, we're going from 5 to 5, bam, that's 0. Excellent, so that's the output. Okay, now we need the derivative. So g prime of x is 2 plus, remember that sign in our back of the room? The derivative of this is f of x. So g prime of 5 is equal to 2 plus f of 5. Let's go back and see what f of 5 is. F of 5 is 81. So that's 83. Done.